Okay, so today we're going to talk about 8.2 areas in the plane. So areas in the plane. And so in areas of the plane, we're going to talk about actually areas between the curves. So if I have a function f of x here, and I have a function that's g of x, okay, notice that between the places that we're looking at from A to B, that f of x is dominant to g of x. In other words, f of x is always going to be greater than g of x here. Okay? So if we're looking at the area between the curve right here, we're going to do just as we did before, right? We're going to go ahead and take a slice or a delta x here, right? And we're going to have to find that height of that delta x. So the height of delta x is what? Nothing more than f of x, because this is f of x, and this is g of x. So it would be f of x minus g of x, and you're going to go ahead and you're going to multiply that by delta x, right here, okay? And then you're going to, so the Riemann sums would be, you would add all these from A to B, right? You would go like that. So in other words, your integral would be what? From A to B, f of x minus g of x dx, okay? Pretty simple, right? It's just the same stuff that we did before when we had when we were looking at f of x and we were looking at the area under the curve here, right? Except for our g of x there was what? Just it was 0, right? Okay? So here we go. So if you look at page 397, on the bottom there's a green box there. Area between the curves, if f of x, f and g are continuous with f of x being greater than or equal to g of x throughout, in other words dominant, between the a and b, then the area between the curves are, just as I always said right here, right? From a to b, f of x minus g of x dx. Okay, so this kind of forebodes also that if they are not dominant, then you're going to have to do something here, right? In other words, if you have, let's say that you had a situation where f of x is here and g of x is here, right? Now, if you're looking between A and B, you have a point here, C, that you're going to have to do something here, right? Because f of x is greater than g of x here, but over here, g of x is greater than f of x. Okay? So keep that in the back of your mind. All right, so let's go and do some examples and see how this works out for us. Okay? So example number 1. Do example number 1, we have what? Find the area of the region between secant squared x and sine x from 0 to pi over 4. So this is example number 1. We have y is equal to secant squared x, and then we have y is equal to, was it sine x, was it? Sine x. And we're going from 0 to pi over 4. If you graph it, you can see that the secant squared x is always greater than sine of x. So we're going to get from 0 to pi over 4 secant squared x minus sine x dx. Okay, so I have to take the antiderivative here. So antiderivative of that is tangent x. Antiderivative of that is cosine x. So it's negative, cosine is going to be positive, right? Be positive. Since we're subtracting a negative. Okay, so it'll be pi over 4, 0. So if I pi over 4 here, I get 1. Pi over 4 here is 1 over root 2. Then I subtract the 0. I put the 0 in. This is 0. Plus this, and when I put the 0 in, this guy here is going to be 1. So this one and this one cancels out. 1 over root 2, 0.707 if you're interested. So that's that. Let's see if we can do example number 2. Area of enclosed, same thing. Number 2. On this one, they're going to actually have us find the region. They're not giving us the region like they did example number 1, or they gave us from 0 to pi over 4. In this one, we said find the area of the region enclosed by the parabola y is equal to 2 minus x squared and y is equal to negative x. So we have y is equal to 2 minus x squared and y is equal to negative x. So I graph this, what do I get? The first one I'm going to get, this is going to be, the y-intercept is 2. This is going to be root 2, negative root 2, right? Because this is where it's 0, so 0, I put it over, I get that. And then we have negative x. So negative x is going to look like that. Okay, so the 2 points that they meet is going to be here, and I want to find this area. Well, in order to find the area, I need to find these 2 points, right? I have to be able to find those 2 points. So what's happening at these 2 points? These 2 points is where this guy is equal to this guy, right? So I've set them equal to 0, set them equal to the same, and I have to solve for x. So I go, move these all over here, I get x squared minus x minus 2 is equal to 0. X minus 2, x plus 1 is equal to 0, which means that x is going to be equal to 2 or negative 1. So this guy here is going to be 2, this guy here, right? And this guy here is going to be negative 1, okay? So we go from negative 1 to 2, and during that time, this guy here is dominant to this guy, right? So in other words, what I'm going to get? I'm going to get the integral of this guy, which is 2 minus x squared, and I'm going to subtract this, I'm going to subtract that, d of x, and I'm going to go from negative 1 to 2. So that's what I'm looking to do here, right? Okay, so if I do this, what is the antiderivative here? I get 2x, negative x cubed over 3, 1/2 x squared, 2 and negative 1, 2 in here I get 4 minus 8 over 3 plus 2, minus, put negative 1 in here, I get negative 2, negative 1 I get plus, like that. So, what do I have here? I have 4 plus 2 is 6. Okay, and this becomes negative and negative. So I get 4 plus 2 is 8. 8, I have negative, negative, so I have negative 9 over 3, which is negative 3. So I took care of that, took care of that, and I have this guy left, so it's minus 1/2. So I have 5 minus 1/2, so it's 4.5. 4.5. Okay. Let's do example number 3. Example number 3. Example number 3. Find the area of the region enclosed by the we just did that one. Find the area of the region enclosed by the graphs of 2 cosine x and x squared minus 1. Okay? So if we do that, we're going to go 2 cosine is going to look like that, right? Or this is 2, and this is pi over 2, negative pi over 2. Okay. And then I have x squared minus 1. X squared minus 1. So it would be negative 1. Negative 1 and 1 here, right? Because this is x squared minus 1. This guy here was 2 cosine x. Okay, so I'm going to go from here to here. Okay, so again, I am dominant. This guy is 2 cosine x is dominant over x squared minus 1 during this region, but I need to find these 2 points. So what do I have to do? I have to set this guy is equal to this guy, right? Okay. Unfortunately, we can't do this algebraically, so we're going to have to look at our graph this and trace it. If we graph and trace it, we find that it is plus or minus 1.265. So x is equal to plus or minus 1.265, okay? So we can go from 0, so we're going to go from negative 1.265, 1.265, and 2 cosine x minus x squared minus minus 1, so it's plus 1 d of x. Alternatively, you can also see that this is the same as 2, 0, 1.265, 2 cosine x minus x squared plus 1 d of x, right? Because both of these functions are symmetric across the y-axis. So from here, so I'm taking this guy's what, from 0 to here, so 0 to here, right? So it's basically this guy, and I'm multiplying that by 2. Okay, so you can do that, and you can do that. So once you find this also, I would just go ahead and mint this, because you're going to have to put this guy into here anyway. Okay, so let's do example number 4. Example number 4. Example number 4 is an interesting thing. So now we still have the dominance, but we will come to a little bit of a problem here. In example number 4, I have find the area of the region R in the first quadrant that is bounded above by y is equal to root x and below by the x-axis and the line x minus 2. So y is equal to root x, and then I have 2, negative 2. This is y is equal to x minus 2. So I want to go from here to here, right? So this is what I'm trying to find. Okay, well the problem is that, okay, first of all I need to know this guy, right? I don't know that, so I have to find that. Okay, so let's find that. Where does that happen? That happens when this guy is equal to that. So I square both sides. X is equal to x squared minus 4x plus 4. I move the x over. X squared minus 5x plus 4 is equal to 0, right? So I'm going to get x minus 4, x minus 1 is equal to 0, x is equal to 4 or 1. Okay, so obviously since this is 2, this guy is going to be equal to 4. But what's the 1? The 1 is actually, when you square this, you're going to get basically what? It's going to be this side over here. Okay, this is the 1 that you found right there. That really doesn't help us, doesn't do anything for us, but that is where the 1 is. When you squared it, you have opened up the other side of the parabola. Okay, so that's what is happening there. So it's 4 is what we're looking for. This guy doesn't help us, so it's 4. Okay, so now what's going to happen? So if I go from 0 to 4, and I go root x minus this guy here, which is going to be x plus 2 d of x, this is incorrect, right? Because now I am introducing this guy here, okay? And I don't want that, okay? Because the bottom limit from 0 to 2 is not x minus 2 here. It is actually the x-axis here, right? So in other words, now I have to split this up into 2 separate regions, right? So the first region is from So we're going to split this up like this, and the first region is from here to here. So it's 0 to 2, so I go 0 to 2, and then the top is still the root x. The bottom is nothing more than this, so it's 0, d of x. Then from 2 to 4, I have this guy is on the top, now this guy is on the bottom here. So I'm going to get root x minus x plus 2 d of x. So I have to split it up in two different parts here. Okay? So let's see if we can do this now. Let's see. So I'm going to get what? 0 to 2 root x dx. So that would be what? That would be 2 over 3x 3 over 2. And I'm going to go 2 to 0. So I'm going to get 2, 3 over 2. That's this guy right here. And this guy here is going to be what? So I did this guy. So let's see if I can do this guy here. I'm going to get what? 2, 3x 3 over 2, just like I did over there, minus 1/2 x squared plus 2x. And I go from 4 to 2. Okay, so if I do that, what do I get? You move it over here. If I get 4, I'm going to get this. Not that. 4, 3 over 2, then I put 4 in here, I get negative 8, 16 minus 2, divided by 2, then I get what, plus 8, and then I put the 2 in, so I'm going to have to subtract the 2, which is, then I'm going to put 2 in here, so a negative 2, then 2 in here, I'm going to get plus 4. Okay? So, these two cancel out. So I get plus 2 here. So I'm going to get 2 over 3, 4, 3 over 2, minus over 2, 2, 3 over 2. Then you're going to have minus 2. Then to that I have to add this guy, right? I'm going to have to add that guy. So basically that cancels out with that. So I'm going to end up with 3 over 2. This is what? What is this? This is the same as, right? So this is 2, so this would be actually 8. So it's 8 times 8, and then minus 2. So I'm going to get, well, this is 16 thirds minus that, so it's going to be 10 over 3. 3.33333. So that this area is going to be 3.333. Okay, or 10 thirds, right?